Saturn is erasing its own masterpiece. Every second, an estimated 800 kilograms of ring material, ice and dust the size of a small car, disappears into the planet. On human timescales, Saturn looks eternal. On cosmic timescales, its rings are a brief, extravagant flare. If you could watch Saturn in extreme fast-forward, over tens of millions of years, you'd see the rings slowly thin, fray, and finally fade into a faint, ghostly halo. The most iconic feature in the solar system is not a permanent structure. It's a transient storm of ice, caught in a delicate balance between gravity, sunlight, and Saturn's own magnetic field. And that balance is failing. To understand why Saturn is losing its rings, you first need to know what those rings actually are, and what they are not. They're not a solid disk, not a cosmic vinyl record. They're an enormous swarm of individual particles, orbiting Saturn like billions of tiny moons. Most of them are water ice, bright and reflective, mixed with a little rock and dust. The main rings stretch from about 7,000 kilometers above Saturn's cloud tops out to roughly 80,000 kilometers. That's more than 6 Earths laid side by side. Yet they're astonishingly thin. In most places, only about 10 to 100 meters thick. If Saturn were the size of a basketball, the rings would be thinner than a sheet of paper. Their total mass is only about that of a small moon, like Mimas. Where did this shimmering debris field come from? There are 2 main ideas. One, a large icy moon wandered too close to Saturn, crossed the Roche limit, the distance where tidal forces overpower its own gravity, and was shredded into fragments. 2, leftover icy material from Saturn's formation never coalesced into a moon, trapped by Saturn's tides and the gravitational tug-of-war between existing moons. Either way, the rings are probably young. Data from NASA's Cassini spacecraft suggests they may be only 100 to 400 million years old. That's younger than the dinosaurs. If that's right, then for most of Saturn's 4.5 billion-year history, it may not have had the glorious rings you see in textbooks. You are living in a very specific, very photogenic moment of Saturn's life. Now to the strange part. Saturn is literally raining its rings. The particles in the rings are constantly bombarded by ultraviolet light from the Sun and by energetic particles trapped in Saturn's magnetosphere. This bombardment knocks electrons off the icy grains, charging them electrically. Once charged, these tiny particles feel not just gravity, but also Saturn's magnetic field. Some of them get nudged onto trajectories that intersect Saturn's upper atmosphere, others collide, grind down into dust, and become easier to drag inward. Cassini measured this ring rain directly. Streams of water-derived molecules, like H3O+ and oxygen-bearing ions, plunging along magnetic field lines into Saturn's atmosphere, especially near the equator and mid-latitudes. It's like a diffuse, invisible waterfall of ring material. As this icy rain falls, it doesn't just vanish, it changes Saturn itself. When water from the rings enters the upper atmosphere, it reacts with hydrogen and other gases, altering the chemistry and cooling certain layers. It may even affect Saturn's banded cloud patterns and its ionosphere, the charged upper region that influences radio waves and auroras. The rings are not just decoration. They're actively interacting with the planet's weather and magnetic environment. Cassini's final orbits in 2017, the so-called grand finale, threaded the narrow gap between Saturn and the inner edge of the rings. During these dives, its instruments could literally taste the infalling material. They detected water, methane, ammonia, carbon monoxide, and complex organics, all streaming down at rates far higher than expected. From those measurements, scientists estimated that the rings could disappear in as little as 100 million years, and very likely within a few hundred million. That sounds long, but in planetary terms it's abrupt. If the rings really formed a few 100 million years ago and will vanish a few 100 million years from now, then their entire bright massive phase is a narrow window, maybe 1 or 2% of Saturn's lifetime. Statistically, it's surprising that we happen to exist during that window. Either we're lucky, or ring systems like this might form and fade multiple times. Saturn isn't alone. Jupiter, Uranus, and Neptune also have rings, but they're faint, dusty, and hard to see. This suggests that bright icy rings might be a temporary, unstable phase that some giant planets pass through. Perhaps a moon is disrupted. A brilliant ring flares into existence, then slowly grinds down and rains away. If so, Saturn's current splendor could be just one episode in a longer cycle of destruction and renewal. This idea has big implications beyond our solar system. When we observe exoplanets, worlds around other stars, we sometimes see strange extended transits. The starlight dims in complex ways as something large and spread out passes in front. One hypothesis is giant ring systems, far larger than Saturn's. If massive rings are short-lived, then catching an exoplanet with spectacular rings would tell us we're seeing it at a very specific stage in its history. Back at Saturn, there's another twist. The rings are getting dirtier. Micrometeorites, tiny grains of rock and metal drifting through space. Over millions of years, this dark material builds up, lowering the ring's reflectivity. Cassini's gravity measurements showed the rings have less mass than some earlier estimates, which supports the idea that they're relatively young and haven't had time to accumulate too much grime. If the rings were ancient, billions of years old, they should be much darker and more polluted by now. Instead, they're still dazzlingly bright. That brightness, combined with their low mass and the rapid rate of ring rain, all point in the same direction. Saturn's rings are a temporary luxury item in the solar system, not standard equipment. They arrived late and will leave early. So what happens as the rings fade? First, the most tenuous outer regions and the delicate structures like the D-ring and parts of the C-ring will erode. Over time, collisions and gravitational interactions will redistribute material, smoothing out sharp edges and gaps. Some particles may spiral inward and fall into Saturn, others may migrate outward or clump into small moonlets, only to be torn apart again by tides. There's a feedback loop at work. As the rings lose mass, their self-gravity weakens, making them more vulnerable to disturbances from moons and from Saturn's oblateness, its equatorial bulge. Structures like density waves and sharp ring edges, sculpted by shepherd moons, may become less pronounced. Eventually, the once majestic rings could resemble the faint dusty rings of Jupiter, still there, but subtle, ghost-like, easy to miss. The deepest question is, how typical is this? Are we catching Saturn in a rare, dramatic phase, or is the universe full of planets briefly wearing bright rings? Right now, we don't know. We have one detailed example. Future telescopes may spot ring systems around exoplanets or evidence of moons being torn apart, giving us more data points. We also don't fully understand the balance of processes that build and destroy rings. How often moons cross the Roche limit? How fast micrometeorites darken the ice? How magnetic fields and atmospheres strip material away? Somewhere in that complexity lies the answer to a simple, haunting question. Are we witnessing Saturn at its peak, or just a typical flicker in a long, ring-making universe? By the time Saturn's rings finally fade, Earth will be unrecognizable, and humanity may be long gone or scattered among the stars. But right now, in this brief overlap of cosmic timelines, you live in an era when a gas giant wears a luminous crown of ice. That fragile beauty is exactly the kind of transient wonder we love exploring here on Terra Nova.